Hello everyone. So in this presentation, we are going to present about one of the finest research findings related to our final year project, that is security on blockchain technology. So first we will see who are the authors and publication details about this research paper. So it has four authors: Mohammed Fadijio, Khalid El Makawi, Saharia Al Alali. So they are from Lamau Laboratory, MSc team, Faculty of Science and Technology, Mohammed Faz University, Nadul, Morocco. And Nabil Kanouf, he is from ACSA Laboratory, Faculty of Science, Mohammed Faz University, Oduja, Morocco. And this was happened in the conference IEEE International Conference on Advanced Communication Technologies and Networking. So the next thing is conference location. It was Marrakech, Morocco, and the date of conference 4th to 6th September 2028. And this paper was cited in 10 research papers, and the publisher is IEEE. So first we will see why this modern technology is going towards blockchain technology. So what are the features for that? So first we will see one by one. The first thing is decentralization. It's like no single authority control the data or transaction in between blockchain. And also all the participants share the same copy of blockchain. And the next feature is immutability. So once data is recorded in the blockchain, it cannot be altered or deleted. And it ensures data integrity and prevents tampering. And the last one is peer-to-peer transactions. It's like direct communication between users without third-party intermediates. So because of these kind of features, now all are willing to keep blockchain in this security related things. So it's widely used in cryptocurrency, voting, IoT, healthcare, energy, and security related things. So this research, now we will see what are the objectives of this research paper. So the first thing is to introduce the basics of blockchain technology, how it's created, how we are going to use, what are the features? So provide a comprehensive overview of blockchain core concepts, components, and its role in decentralized system. And the next one, to identify key blockchain security vulnerabilities. Even it's safer, still it has some security vulnerabilities like 51% attack, wallet attacks, double spending attacks, smart contract vulnerabilities. These things will be talked in later slides clearly. And the next objective is to discuss blockchain security countermeasures, like how we can prevent these attacks, like explore practical solutions and defense such as multi-signature wallets and cold storage solutions, decentralized mining pool systems, performance, performance and performance and security analysis frameworks, smart contract auditing tools like OINT. And the last one, to summarize the importance of blockchain security. It's like empathize how addressing these vulnerabilities can strengthen blockchain applications in fields like IoT, healthcare, identity management, energy, and security related parts. So the next slides will be explained by Nimashagan.
Thank you, Kidurshika, for the great introduction. I will now explain the key components of the blockchain technology and how they contribute to its structure and security. Yes, let's begin with the ledger. In the blockchain, the ledger is a distributed and immutable record of all transactions once the transaction is added. It cannot be changed or deleted. This is what provides blockchains high transparency and security. Next is the peer network. Blockchain operates on a peer-to-peer network Every node or participant keeps a complete copy of the ledger. These nodes store and update the ledger using consensus protocols with no need for central authority. That's the key advantage of the peer-to-peer network. Let's move to the smart contracts. These are self-executing programs that automatically carry out transactions when certain conditions are met. This saves a lot of time and removes the need for intermediaries. Next, the wallet that securely stores user credentials and key pairs without the private key in the wallet. No transaction can be signed or approved, which adds a strong layer of security. And events are the real-time notifications sent across the network. For example, when a new block is added or a smart contract is triggered, everyone in the system gets an update about that. Next, the system management. This is the in charge of monitoring blockchain operations. It helps keep the system healthy and scalable as the network grows. Finally, the system integration that connects the blockchain to external systems like university portals and the payment platforms and many other systems related to the blockchain. And yes, let's dive into the blockchain architecture. The blockchain architectures are built by several layers, each with the unique purposes. Let's start with the data layer. This is the layer where all the blockchain data is stored securely, and it uses the encryption, hashing, and Merkle trees to protect the data. Each block is connected to the one before it, and making it impossible to alter the history. Next is network layer. This layer handles the communication across the peer-to-peer network and sharing the transaction and block updates between all nodes quickly and securely. Next, the consensus layer that ensures that everyone on the network agrees on which transactions are valid, and it uses protocols like POW, proof of work, and POS, proof of stake, to prevent fraudulent activities. Next, the incentive layer that is designed to reward the participants like mining or validators for contributing to the blockchain network. This motivates the users to maintain the system honestly. Next, the contract layer that runs smart contracts automatically. This layer ensures that transactions and agreements can be executed without manual approval, making the processes very fast and more secure. Finally, the application layer is where the users interact with the blockchain. This is the layer that the real-world application meet, like cryptocurrency wallets and healthcare system, voting platforms, and many other security-related systems, applications. And each layer here builds on the previous one and creating the system that is decentralized and transparent and reliable. Thank you for your attention. And now I would like to hand over to my friend Dhananjayan to continue with the next part of our presentation. Thank you.
Thank you, Nivasagan. Now I explain about use cases of blockchain. Blockchain technology is transforming many real-world applications. Let's go through some key areas where blockchain is making a significant impact. First, in healthcare, blockchain helps securely manage electronic medical records. For example, MedChain provides a decentralized solution where patients and doctors can access medical records efficiently and securely. Next, in voting system, blockchain ensures transparency and trust. A great example is Luxoft's blockchain-based e-voting platform, which was successfully used for online consultations in Switzerland. This platform solves many of the security gaps in traditional e-voting systems. For identity management, blockchain supports self-sovereign digital identities that give individuals full control over their personal data. The Life ID platform is one of such systems. When we look at the Internet of Things, security and scalability are major concerns. Blockchain technology offers a reliable solution while securing communication between IoT devices and maintaining data integrity. Finally, in the energy sector, blockchain enables smart solutions like the Clenergy Metro smart meter, which can automatically track energy production and consumption in real time, improving energy efficiency. Let's move on to the next slide. Although blockchain offers powerful security advantages, it also has several critical vulnerabilities. The first major threat is 51% attack. This happens when a malicious entity gains control of more than half of the network's computing power. When this happens, attackers can rewrite the blockchain transaction history, potentially reversing transaction and enabling downspending. Wallet attacks are another serious issue. Blockchain wallets rely on public and private key pairs. If a user's private key is poorly managed or the cryptographic algorithm is weak, hackers can steal funds. Once the private key is compromised, it's almost impossible to recover the lost assets due to decentralized nature of blockchain. Next is the double spending attack, where the same cryptocurrency is used for multiple transactions. In proof of work blockchain like Bitcoin, if an attacker acts quickly within the block confirmation time, they can trick vendors and effectively spend the same Bitcoin twice. This undermines the trust in blockchain immutability. Finally, smart contract vulnerabilities pose a significant risk. For example, the famous DAO attack in 2016 exploited a re-entrancy bug, allowing an attacker to drain over $60 million. Smart contracts are irreversible, so any mistake in their code can lead to severe consequences. These vulnerabilities highlight the importance of continuous improvement and security focused in blockchain systems. Thank you so much. Now I hand over the presentation to Sadhusan. He will continue.
Thank you, Dhananjayan. Through the key conclusion and the future direction of this study. First, after analyzing the paper and its finding, it's clear the blockchain technology offer significant advancement in security and decentralization. It provides a robust structure where transactions are securely recorded and shared across the peer-to-peer network without the need for central authority. This creates trust and transparency in the system. However, like any technology, blockchain also come with its set of vulnerability. Among the most critical are the 51% of attacks where attackers could gain majority control of the network. While additionally, quantitative security frameworks provide in-depth analysis of blockchain performance and security, while tools like OITs are recommended to detect bugs in smart contract before they go live. Now, looking at the future work, several exciting directions to explore. Firstly, strengthening public key infrastructure is crucial to maintaining high cryptographic security standard. This includes researching advanced key management system and preparing blockchain system for future threats by exploring post-quantum cryptographic solutions. Secondly, blockchain performance need to be optimized, especially for IoT environment, where devices are resource limited and require fast, lightweight transaction. By developing energy efficient consensus mechanism and lightweight protocol, we can make blockchain practical for large-scale IoT development. Lastly, to appear Emphasis the transaction processing speed must be improved to support real-time application, especially in dynamic environments like IoT and financial system. By focusing on this future improvement, we can make blockchain system even more secure, scalable, and adaptable to wide range of industries. And thank you so much for your attention.